Hello students, today we are going to go over graphing linear inequalities. So objective, I can graph a linear inequality. Now what is an inequality you ask? Well, let me go ahead and write it in here. The notes are going to be a linear inequality involves a linear expression in two variables. And those variables are x and y, and by using one of these symbols. Okay, an example would be y is greater than 2x plus 1. That would be an inequality. So graphically, the point xy is where the inequality is, and it'll be shaded. And algebraically, it's the point xy that makes the inequality true. Okay, next, as an example, determine which ordered pairs are solutions to the linear inequality. And we're going to find out algebraically. So we're going to plug this point into this inequality, and we're going to find out if it's true. So if I put 2, because I put 2x, I'm going to put x is 2 here, 2 times 2 minus 3 from here, our y is 5. Is that going to be less than 15? Okay, 2 times 2 is 4. Minus 15, because I multiplied those. You do multiplication before subtraction. Is that less than 15? 4 minus 15 is going to be negative 11. Is that less than 15? And the answer is yes. So if I get an answer of yes, that's going to be a solution of that inequality. So we know that if we were to graph it, 2, 5 would be shaded. Now let's find out if negative 1, negative 7 is a solution to this inequality. So I put the equation again as 2x minus 3y is less than 15. 2, and then I put my x, negative 1, minus 3, and I put my y, negative 7. Is that less than 15? Okay, so I'm going to multiply negative 2 plus, and I'm going to put plus a negative 3 times that is 21. Is that less than 15? So negative 2 plus 21 is 19. Is 19 less than 15? And the answer is no. So if the answer is no, we know that this is not a solution. Negative 1, negative 7 is not a solution to that inequality. Now, I want you to go ahead and stop the video and do the next 2 points, and then start it back up and we'll go on. Okay, so next we're going to talk about graphing linear inequalities. It's a way to show all the ordered pairs that are solutions. The solution to an inequality is a half plane. And here's the steps to graph. Put the inequality in slope-intercept form. So that's going to be slope-intercept form. Do you remember what that was? Slope-intercept is y equals mx plus b. But in this case, it will probably be more like y is greater than mx plus b, or y is less than mx plus b. So I'm going to go ahead and fold that over so you can see it a little bit nicer there. And we'll continue. Okay, so be sure to flip the inequality symbol if you multiply or divide by a negative number. Okay? So next, when we're shading it, after we put it in slope-intercept form, we're going to use a dotted line for greater than and less than symbols. And we use a solid line for greater than or equal to or less than or equal to symbols. So it's kind of the same as what I taught you before. that if it's more ink here, it's going to take more ink there. That means these two will include the line as part of the solutions, and these two do not include the line as part of the solutions. Then we shade below the line for greater than, for less than or equal to symbols. And then we shade above the line for greater than or equal to symbols, okay? And a way to think about that is I think of the line as a ladder, okay? And when the ladder falls, that's going to be where it's less than, okay? And where the ladder would not fall is going to be greater than. So that way you can tell if you've got the correct part shaded. Another way is to choose a point. Normally I choose 0, 0. So if I was going to choose 0, 0 here, it's shaded, so it should be a true solution. So is 0 less than 0 plus 1? Is 0 less than 1? So again, you go 0 less than 0 plus 1 is 0 less than 1. We can say yes, and so 0, 0 shaded. Over here, that would not work. 0, 0 is not shaded, so I could go is 0 greater than 0 plus 1? Is 0 greater than 1? And the answer to that is no, so that means 0, 0 should not be shaded, okay? Now you go ahead and do these two to find out if 0 should be shaded, 0, 0, or if it should not be shaded, okay? All right. Good luck, students. Have fun. You rock.